Today we're going to be looking at solving exponential equations where our bases are not the same. So all the problems we've done before have had the same base, but today we're going to be looking at situations where the bases are not the same. The only difference between what we did yesterday and today is we need to create the same base, and this chart is going to be very helpful to you. Now eventually you'll memorize the information that's in this chart, but for now, I want us to rely on this chart because it's going to show you how quickly we can convert bases. So take a minute, pause the video, fill in this chart, and when you're ready, we can move on. Don't be afraid to use a calculator when you're doing this chart. Okay, use a calculator, fill it in, and then start the video again when you're done. Okay, hopefully these are the answers you got. Take a minute, again, pause the video, check your answers, make sure you have everything the way I do, and then we're going to be ready to move on. Okay, so before when we did problems, the very first thing we had to do was check and make sure we had the same base. Today, we're not going to have the same base, so we have to figure out how we can convert a number into a different base. So in this situation, all of these numbers here on the left, we're going to try to convert to some power of 3, and we're going to use our chart to help us. So, for example, looking at 9, okay, if I look for 9 on my chart, I can see that 9 is equivalent to or equal to 3 to the second power. So all I'm doing is figuring out what power of 3 is equal to these numbers. So take a minute, you can use your chart, you can do this with me if you want to. But otherwise, just, you can either pause the video and do it on your own, or you can do it with me. 81. If I find 81 on my chart, it's down here. 81 is equal to 3 to the 4th. 1/9 is up here. That's equivalent to 3 to the negative second power. And finally, 243. 243 is all the way down here, equal to 3 to the 5th. Okay, now this is just to show you how we can change bases of numbers. So take a minute again. This time we're looking at powers of 2 and powers of 5. Be very careful as to which chart you use. You can pause it and do it, or you can do it with me. It's up to you. So 32, and what I'm looking for is a power of 2. So that's going to be in this chart here on my left. 32 is equivalent to 2 to the 5th power. 1/8, again, we're looking for a power of 2. So that's over here. 1/8 is equivalent to 2 to the negative 3rd power. 125, power of 5 we're looking for, so 125 is right here, 5 to the 3rd power, and 1/5 with the power of 5 is right here, 5 to the negative 1st power. All right, so what you've done here is you've changed bases, and this is now going to be the first step when we're looking at solving exponential equations if our bases are not the same. And as I said, I want you to use this chart, so feel comfortable using this chart as you do these problems. So before, we said to solve an exponential equation, we had to have the same base. If your bases are not the same, you have to change one or both of the bases so that they're the same. When you look at this problem, we have a power of 2 and a power of 8. Power of 2 is the simplest power we have. We can't change that. Or we could change it into another number. But what we're going to do is we're going to take that power of 8 and change it into a power of 2. Here's how we're going to do it. Okay, I want you to think about the chart we just made. Hang on, where's my chart? There it is. Okay, so when we think about powers of 2, 8 is the same as 2 to the 3rd power. So 8 is the same as 2 to the 3rd. What I'm going to do is I'm going to take this 2 to the 3rd power, and I'm going to replace this 8. Okay, because 2 to the 3rd equals 8. Now, I still have that original exponent of 4. Okay. Now, this number already had a power of 2, so I don't actually have to change that one at all. I'm going to write it exactly the way it was. Now when you look at this problem, hopefully it looks similar to what we did yesterday because now we have the same base. Since we have the same base, we can just cancel out those bases, and then we're going to write our exponents as an equation. okay? And then it's time to just simplify and solve. So my first step here is going to be 3 times 4, which is 12. So I have x plus 7 equals 12, and then I'm just going to solve it. So I'll undo this addition, and I'll find out that x equals 5. What that's saying is if I were to go back to my original equation, right up here, and I did 2 to the 5 plus 7, which is 2 to the 12th, that would give me the same answer as 8 to the 4th. Okay, so what we're doing is we're figuring out these exponential equations. Now, just like I did last time, or a couple times ago, there are 4 practice problems for me to do with you. I'm going to do a couple of them, and then if you think you've got the idea, you can move on and finish up the paper on your own and do your on your own problems. If you want to stick with me, I'll go back and I'll do all the other problems too. So I don't want you to feel like you have to watch every single problem, but I do want you to watch the next 2. So when we look at this, we've got a 5 and a 25. Those are not the same base, so what I need to do is change them to the same base. And what we're looking at is a base of 5. So obviously this one, 5 to the 5x, that already has a base of 5. It can stay just like it is. 25, however, we're going to change that to 5 to the 2nd power. So what I've done is I've replaced this 25 with 5 to the 2nd power. Now don't forget, I still have this original exponent, which I can't forget about. Okay? Now when you look at this, we have the same base. I can cancel out the bases and set up these exponents as an equation. And then all I need to do is solve it. Now this equation needs to be distributed, so we're getting into a little more complex equation here. So now I've got 2x plus 6. And now it's time to solve it. I have to move my variables to the same side. So I'm going to move this 2x over to the other side, and I get 3x equals 6. And then I have to undo that division or that multiplication by dividing by 3. And I get x equals 2. Okay? All right. I'm going to skip ahead. I'll come back to this one. And oops, I didn't clear that off from the last time I did this problem. I'm actually going to do the problem on the right here, because this one on the right is probably the most complex of the problems that we're going to do. And then if you still want to work with me, I'll go back and do the other 2 problems. But I at least want everybody to see this one. So what we've got here is a base of 4 and a base of 8. Okay? And we need to have the same base. A lot of kids would say, oh, well, we can just turn an 8 into a 4. But we actually can't do that, because if you think of our powers of 4, 4 to the 1st power is 4. 4 to the 2nd power is 16. Okay? So we can't use our power of 4 here. What I'm going to do is I'm going to use a power of 2. Now there are a couple different ways to do this problem. I'm going to use a power of 2. Okay? So let's get our chart for our powers of 2. 4 is the same as 2 to the 2nd power. And 8 is the same as 2 to the 3rd power. Okay, so I've got those 2 powers of 2 now. And we just have to remember we still have our original exponents that we can't forget about. Okay, so now let's cancel out these powers of 2 and rewrite these exponents as their own equation. So I've got 2 times 3x plus 3 equals 3 times x minus 2. We got to use our distributive property here, and we actually have to distribute on both sides. So I'm going to end up with 6x plus 6 is going to be equal to 3x minus 6. All right, so now let's solve this. Move our variables together. I'm going to move this 3x over here, and I'm going to get 3x plus 6 equals negative 6. Give me a second. I got to move this chart out of the way. Not what I intended to do. Hang on. give it one more shot and try to move this out of the way. There we go. All right. So now I'm going to undo this addition by minus 6 here, minus 6 here. That's going to give me 3x equals negative 12. And then finally undo this multiplication, and I get x equals negative 4. Okay? Now, if you are confident that you can do the rest of the problems on your own, go ahead. Feel free to go back and watch the answers to the other 2 problems, and we'll go over the on your own problems to get tomorrow in class. But everybody else, if you want to stick with me, let's stick together. So I have the power of 3 over here and 1/9, which I know I can change 1/9 into a power of 3. So I'm going to look at my chart. 1/9 is the same as 3 to the negative 2nd power. I'm going to move that out of the way there. And I see 1/9 is right here. So this is going to be 3 to the negative 2nd power. Everything else is going to stay the same. And I have my original exponent here. All right, now it's time for me to cancel out my bases and write these exponents as their own equation. And now let's solve. So x plus 4 is going to equal negative 6. I need to undo this addition. And I'm going to get x equals negative 10. All right, one last problem, and then everybody will be on their own. So I want to look at this. I have 81, and I have 3. I'm looking for powers of 3. So I know that 3 is already a power of 3. I know that 81 can be 3 to the 4th. I can't forget that original exponent of x minus 2. And then I have my other power of 3 over here. So now my bases are the same. I can cross off my bases, and I can set this up as its own equation. I'm going to do my distributive property right here. So I'm going to get 4x minus 8 equals 3x plus 1. And it's time to move my variables together, so I'm going to move this 3x over. And that's going to leave me with 1x minus 8 equals 1. And now I got to move my numbers together, so I'm going to undo this addition or this subtraction. And I'm going to get 1x equals 9. All right, so go ahead, do the on your own problems, and we'll talk tomorrow in class.